Hello everyone, welcome back to my channel. In today's video, we're going to continue the paper 2 Pahang paper, which is question 7 until 9. Are you ready? Let's go! Let's look at question number 7. This question is under linear law. Use the graph paper provided to answer this question. So you'll be given a graph paper and you have to use it. Okay, and the graph that you draw must occupy at least 80% of the whole graph paper. Okay, it cannot be too small, it cannot be too big. So you have to follow the scale given in the question. Okay, let's read on. Table 2 shows the values of two variables x and y obtained from an experiment. Variables x and y are related by the equation, so this equation is very important. Okay, so y equals to p over x plus 1 holding power k, where k and p are constants. So they give you a table x and y, okay, and then we read on for A, plot log y against log x plus 1. So log y is going to be the y-axis, and then log x plus 1 is going to be on the x-axis. And using a scale 2 cm to 0.1 unit on the log x plus 1 axis, and 2 cm to 0.2 units on the log y-axis. Hence, draw the line of best fit. So what is the meaning of line of best fit? So it means that when you plot the graph, okay, all the points, so when you use a ruler to join all the points, okay, you try to join as many points as possible. Okay, if not possible, you make sure that there will be one on the left and one on the right, so that it will be balanced, and then the line must be in between the 2 points that you didn't cut. Okay, so make sure that you try to draw try to connect all the points as possible, as many as possible, okay, to get the line of best fit. Okay, so when we draw the graph, before we draw the graph, okay, so we look at this table. So we have to find the values of log y and log x plus 1. Okay, so here I've already prepared a table. Okay, so in exam, you have to draw out this table, okay, and show to the examiner. So when you plot the graph, it will be based on this new table. Okay, so now let's do this. So here will be the log 10 x plus 1, and here will be log 10 y. Okay, so based on the above table, so log x plus 1, it means that log x is 0.5 plus 1 is 1.5. So log 1.5, when you use the calculator, is 0.18. Okay, round up to 2 decimal places. Okay, so you get 0.18. So 0.18. And then log 1 plus 1 is 2. So log 2 is 0.30. Okay, so 0.30. And then log, okay, 2 plus 1 is 3. So log 3 is equals to 0.48. Okay, 0.48. And then log, okay, 3 plus 1 is 4. So log 4 is equals to 0.60. So 0.60. And then log 4 plus 1 is 5. So log 5 is 0.698. So 0.70. Okay, 0.70. And then log 5 plus 1 is 6. So log 6 is equals to 0.78. So 0.78. Okay, and then now we're going to find log y. Okay, so log, okay, y here is 9.277. Okay, so log 9.277. Log 9.277 is 0.97. Okay, give in 2 decimal places, 0.97. And then log 4.571. Log 4.571 is 0.66. Okay, 0.66. And then log 1.555. So log 1.555. So we get 0.19. Okay, so 0.19. And then log 0.750. So log 0.75 is equals to, okay, negative 0.12. So negative 0.12. Okay, and then after that log 4, so it'll be log 0.418. So log 0.418. So we get negative 0.38. So negative 0.38. And then lastly, log 0.251. So we get negative 0.60. So negative 0.60. Okay, so based on this, After that, we draw the line of best fit. We plot it first, okay, and then we draw the line of best fit. Okay, let's say this is the graph paper that is given to you. So firstly, you have to draw the x-axis and the y-axis according to the scale given. Okay, so for here, the x-axis is log x plus 1 and the y-axis is log y. So the first point is according to the table that we have drawn just now. Okay, so the first point is 0.18, 0.97. So 0.18 and 0.97, the first point is here. Okay, and then after that, the second point is 0.3, 0.66. 0.3, 0.66 is here. Okay, then the third point, 0.48, 0.19. 0.48, 0.19 is here. And then the fourth point is 0.60, negative 0.12 is here. And then the next point, 0.7, negative 0.38. So it's here. And then lastly, 0.78, okay, and negative 0.6 is here. And then we use a straight ruler, and then we join all the points together, and we try to get a straight line until it cuts the y-axis. Okay, so it's going to be here. It's just join with a ruler. Make sure you have a long ruler during exam so they can join them together. Okay, so that will be the graph that is required. Yeah, and then after that, we can answer the question in B. Okay, now let's look at question B. Using the graph in 7a, find the value of k, p, and y when x is equals to 1.3. Now let's look back at the graph that we have drawn just now. So this is the graph, okay? So the equation that is given in the question just now, the original one, is y is equals to p over x plus 1 to the power of k. So this is in non-linear equation. Okay, so we have to change it into the form of linear equation, which is y equals to ms plus c. Okay, so we have to put log for both sides, log at both sides. So log 10 y equals to log 10 p and minus k log 10 x plus 1. Okay, then after that we have to rearrange it in the form of y equals to mx plus c. Okay, so this one will remain on the left equals to, this is our m, then x plus c. Okay, so which means that this is my big Y equals to, this one is m, this one is x, okay, then plus, this one is c. Okay, so we already got the equation in linear form. Okay, so now we can answer the question. So for number 1, we need to find the value of k. So negative k is the gradient. Okay, so the gradient is negative k. So negative k is the gradient of the graph. So we find the gradient. Okay, so to find the gradient, I'm going to use the difference in the y axis here to here. Okay, then over the difference in this. Okay, so which is equals to, so this is 1.44. Okay, here is 1.44. Yeah, and this is 0. Okay, so 1.44 and minus 0 over, so this is 0.55, this is 0.55. Okay, so 0.55 then minus 0. So let's calculate this. 1.44 divided by 0.55, so we will get 2.618. Okay, but before that, this is negative, because the graph is going down, so it's a negative. So this is negative 2.618 and this is negative k. So therefore, k is equals to 2.618. Okay, so that is the answer for B1. Okay, now let's solve for P. Okay, where is P? So P, can you see here in the C, the y-intercept, log P. Okay, so for number 2, I'm going to write my working here. So log 10P is the y-intercept. Okay, so in the graph, the y-intercept is 1.44. Okay, it's 1.44 here. So 1.44, yeah, so log 10P is equals to 1.44. So in order to find P, I bring over the base 10 to the right side, becomes 10 to the power of 1.44. Okay, so let's calculate this. What is 10 to the power of 1.44? 10 to the power of 1.44 is equals to 27.54. Okay, give your answer in 2 decimal places. Okay, So 27.54. Okay, so lastly is, okay, what is y when x is equals to 1.3? Yeah, so I'm going to use another color pen. Okay, so I try to use a space here. Okay, so I'm going to sub it into the original equation, which is this one. Okay, y equals to p over x plus 1 whole thing to the power of k. So I'm going to substitute my p that I've gotten just now, which is 27.54, and I'm going to substitute my k, which is 2.618. Okay, and then I'll be able to get the answer. Yeah, so I'm going to substitute it. So I'm going to write it here. So y is equals to, so p is 27.54, okay, over, then my x, okay, my x is 1.3 plus 1. Okay, and then after that to the power of 2.618, because my k is 2.618. Okay? Yeah? Okay, then after that, let's calculate this. Yeah? This is when x is equals to 1.3. So 1.3 plus 1, after that I power 2.618. And then with the answer, I use 27.54 divided by the answer. Okay, so I will get 3.11. Just give your answer in 2 decimal places, and that will be the final answer. Okay, now let's look at question number 8. So this question is under the chapter Coordinate Geometry. So diagram 4 shows a straight line QR intersects the straight line PQ at point Q. So where is point Q? So here is point Q. Okay, here, the intersecting point. Okay, so given the equation of the straight line QR is 3y minus 2x minus 19 equals to 0. It means that, okay, this one, I'm going to change it into the form of y equals to mx plus c. Okay, so it will be, okay, let me write down 3y minus 2x minus 19 equals to 0. And I'm going to change it to become, okay, so 2x, then plus 19. Okay, so all divided by 3, so it'll be 2x over 3 plus 19 over 3. It means that the gradient, okay, for this, this is the first gradient, is equals to 2 over 3. Okay, so which means that to find the gradient of PQ, because they ask for equation of the straight line PQ, okay, so to find, let's say this is M2. So I'm going to use M1, M2 equals to negative 1 to find the gradient of the normal line. Okay, so 2 over 3 dot m2 equals to negative 1. Dot means times. Okay, so the second gradient, the gradient of the normal line is, so 2 over 3 shift over to the right hand side, it becomes negative 3 over 2, which means that this is negative 3 over 2. Okay, so now to get an equation of the straight line, so we just need a coordinate and the gradient. Just these two info will do. Okay, after that I'm going to sub into the equation y minus y1 equals to mx minus x1. Okay, so we have to memorize this one. Yeah, so y, so the coordinate I'm going to use is p, because this p lies on the straight line PQ. Okay, so y minus 2 equals to negative 3 over 2 x minus 0. So y is equals to negative 3 over 2x then plus 2. Okay, that will be the answer for A1. Okay, that's the equation of the straight line PQ. Okay, next we have to find the coordinate of Q. So to find the coordinate of Q, we already gotten the equation of this line and also this line. Okay, so Q is the intersecting line. We're going to use simultaneous equation method to find the intersection. Okay, the point of intersection. Yeah, so this is the first answer, and this will be the second. I'm going to write it over here. Okay, so to find the coordinate of Q, so the first equation was y equals to 2x over 3 plus 19 over 3. Okay, then the second equation, this is the first one, and this is the second equation. Okay, so this is the first one, and then the second equation is y equals to negative 3 over 2x plus 2. So I'm going to use simultaneous equation. Okay, equation 1 equals to equation 2, okay, to find my value of x and y, which is the point of intersection. Okay, that is the coordinate of Q. Okay, so 2x over 3 plus 19 over 3 equals to negative 3 over 2, okay, 3x over 2, then plus 2. Okay, so let's solve this and get the value of x. So 2x over 3 plus 3 over 2x, okay, then equals to, then 2 minus 19 over 3. Okay, so I'm going to continue over here. Okay, let's calculate this. So 2 over 3 Then after that, plus 3 over 2. Okay, so we get 13 over 6x. So 13 over 6x. And then equals to, so 2 minus 19 over 3. So we get negative 13 over 3. So to find x, I'm going to bring the 13 over 6 over to the right hand side. So I'll multiply by 13 over 6. Okay, so I will get a coordinate. So this is negative 13. So I will get, so 13 over 3 times 6 over 13. So I will get 2. Okay, so I will get negative 2. So after that, I'm going to sub this into equation 2 to find my y. Okay, so I'm going to find my y. So y equals to negative 3 over 2x plus 2. So x is negative 2 plus 2. Okay, let's solve this. So we can cancel this. We can cancel this. So it becomes positive 3 plus 2, which is 5. Okay, so which is 5. So our coordinate q is equals to, therefore q is negative 2, 5. So that will be the answer for A2. Now let's look at question B. The straight line PQ is extended to a point S, negative 5, 19 over 2, such that PQ to PS is equals to M to N. Find the ratio of M to N. Okay, firstly, I'm going to draw a straight line. Then I'm going to mark the points. So here, okay, so this will be S, which is negative 5, 19 over 2. And then after that, we have Q. This is Q, which is negative 2, 5. And this will be P, which is 0, 2. Okay, then I'm going to mark where is the M. So we know that PQ is M, okay, which is M here. So PQ is M, but PS is N. So P to S is N, not Q to S. So therefore, this will be N minus M. Okay, so now I'm going to sub into the formula. Yeah, so the formula, let's say this one, I put it as x1, y1. This is x2, y2. Okay, I'm going to sub into the formula. Yeah. So I hope you still remember the formula. So negative 2, 5 will be on the left. So equals to M times with negative 5. After that, we plus with N minus M times with 0. After that, we plus the ratios together. So M plus N minus M in big bracket. Okay, then comma. So M times with 19 over 2. After that, plus with N minus M times with 2, and then after that over M plus N minus M. Okay, after that I'm going to compare the left hand side. Okay, this negative 2 equals to this. Okay, to find the ratio M to N. So negative 2 is equals to negative 5M plus 0 and over. So M plus N minus M is N. Okay, so now we have negative 5M over N, negative 2. So this negative 5 I shift over to the left hand side, become negative 2 over negative 5, which is M over N. So now we already gotten the ratio. So M over N is equals to 2 over 5, which means that M to N is equals to 2 to 5. So that will be the answer. Okay, now let's look at B2. Find the area of triangle PRS. So first of all, I'm going to write down all the coordinates of P, R, and S, so that after that, I can just substitute into the area formula. Okay, so P is 0, 2. Okay, and then R is negative 5, 3. And then S is negative 5, 19 over 2. So now I'm going to substitute into the area formula. So area of triangle PRS is equals to half and then modulus. Okay, so I'm going to start with P first, yeah? 0, 2. Then after that, followed by R, which is negative 5, 3. And then followed by S, so negative 5, 19 over 2. And then followed by the first point, which is 0, 2. Okay, so now I'm going to times them together. So this times this, plus this times this, plus this times this. Okay, after that, we minus this times this, minus this times this, minus this times this. Okay, so let's do this. So half remain outside. So 0 times 3 is 0. Then negative 5 times 19 over 2. Okay, let's calculate. So negative 5 times 19 over 2. So we get negative 95 over 2. So negative 95 over 2. And then after that, plus negative 5 times 2 is minus 10. After that, we minus. Okay, 2 times negative 5. Okay, I don't have to put a bracket. So minus minus become plus 10. Then minus minus plus 15. Then minus 19. This one will be 0. Okay? So let's calculate this. So we have negative 95 over 2. Then after that, minus 10 plus 10, then plus 15. So we get negative 65 over 2 in the bracket. So half, okay, negative 65 over 2. So when we open up the modular sign, it becomes positive. Then we times with 1 over 2, okay, so we get 65 over 4. And we change it into a mixed number. So we'll get negative, okay, we get positive 16 1 over 4. So that will be the answer. And the unit is in unit square. Okay, so that's the answer. Okay, now let's look at question C. A point T moves such that its distance from point Q is always 5 units. Find the equation of the locus of point T. Okay, so for this, it's always 5 units. It means that the radius is 5 units, means it's a circle. Okay, we know that the locus is a circle. So I'm going to use the circle formula, x minus. So point T, okay, point T I make it as xy, and then Q I make it as, because the question given as negative 2, 5, okay, so it will be x minus negative 2, okay, then whole thing square, plus, then y minus 5, whole thing square, and then you square root this whole thing, and equals to 5, okay, so now we square both sides. So become x plus 2 whole thing square plus y minus 5 whole thing square. Then this will be 25. 5 square is 25. Okay. After that, we are going to expand all the brackets. So here will be x square plus 4x plus 4. Then plus y square minus 10y plus 25. Then minus 25 equals to 0. Okay. So now we rearrange it. So x square plus y square. After that, we have plus 4x, and then we have minus 10y, and then we have plus 4. Okay, so make it equals to 0, and that will be the equation of locus. Okay, now let's look at question number 9. So prove that tangent 3x is equals to the right-hand side. So I'm going to use this to prove the right-hand side. For this formula, okay, I'm going to use 2 formulas for this question. So the first formula will be tangent A plus B. Okay, you can get this formula from the formula sheet given during exam. So equals to tangent A plus tangent B. Okay, then over. Okay, now let's look at question number 9. So this question is under the chapter Trigonometry. So for this, I'm going to prove tangent 3x, which is the left-hand side, equals to the right-hand side. So for this, I'm going to use 2 types of formula. Okay, so the first formula would be tangent A plus B. So tangent A plus B is tangent A plus tangent B over 1 minus tangent A tangent B. Okay, and the second formula is tangent 2A. So tangent 2A is 2 tangent A over 1 minus tangent square A. Okay, so now let's solve this problem. So this question is tangent 3x. So I'm going to split it up into tangent x plus 2x. Okay, which means that I'm going to use the first formula, which is x, and this will be 2x. So therefore, he'll be x, he'll be 2x, he'll be x, and he'll be 2x. Isn't that simple? Okay, so equals to, so here will be tangent x plus tangent 2x. Okay, then after that, over 1 minus tangent x, tangent 2x. Okay, so now there's a tangent 2x here. I'm going to use this formula. Okay, so it will be tangent x plus, so tangent 2x will be 2 tangent x over 1 minus tangent square x. Okay, then after that, whole thing over 1 minus tangent x, okay, times with 2 tangent x over 1 minus tangent square x. Okay, like that. Then after that, I'll make the two denominators equal for the top. So it will be 1, okay, tangent x. Then after that, minus tangent cube x. Then after that, plus 2 tangent x. Okay, we can forget about the denominator because we can cancel with the bottom denominator. Okay, and over. So the bottom one will be, so it'll be 1 minus tangent square x. Then after that, minus 2 tangent square x. Okay, so after that, we solve the top. So tangent x plus 2 tangent x is 3 tangent x. Okay, then minus tangent cube x. Then after that, over. For the bottom one will be 1 minus, so tangent square x, negative tangent square x minus 2 tangent square x, we get negative 3 tangent square x. Okay, so we have already proven because it's the same as the question. That is the answer. Okay, now let's look at B. This is sketching the graph. Okay, sketch the graph y equals to 1 minus tangent 3x for x between 0 and pi. Okay, so pi is actually 180 degrees. So we're going to draw this. Okay, before that, I'm going to explain to you what is tangent, what is the graph of tangent x, okay, and then what's the graph of tangent 3x, and what's the graph of negative tangent 3x before we can get the answer, okay, so that you all can understand better. Okay, so I might need some time to explain because it's, for this question is very important. Okay, so if you think that you already understand, you can fast forward this video. Okay, so I'm going to start drawing now. So for graphs, normal graph, which is tangent x, okay, y equals to tangent x. This is a normal graph. This is x. So let's say it's between, this is 180, which is, let's say, pi, and this is 2 pi. So a normal graph will look like this. Okay, so it will look like this. Okay, that is a normal tangent x graph. Okay, so what if it's tangent 3x? So tangent 3x means there will be 3 cycles between 0 to 2 pi. Okay, so 2 pi is 360. So you divide by 3 means one cycle is about 120. 360 divided by 3 is 120 for one cycle. Okay, so let me draw this. If it's 120, yeah. Okay, so I'm going to split it up into like this, 620 and 180. So this is pi. I say this is 120 degrees and this is 60 degrees. Okay, and the pi is 180 degrees. So I'm going to write that as 180 so that you guys can understand better if it in terms of degree. So this is 180 degrees. Okay, so it will be, it will look like this. Okay, and after that it will be like this. It's going to the infinity. And then after that, the graph will go up here. Okay, so it will look like this. This is for graph y equals to tangent 3x. Okay, what if there's a negative? So y equals to negative tangent x. So it will be from the top will bounce to the bottom. Okay, so I'm going to draw back 60, 120, and 180. This is x. Okay, so this is the origin. So from there is top, so we bounce to the bottom, so it looks like here, going down like that. Okay, and this will be going up. Okay, then it's going down, and then here will be going up. Okay, and then here will be going down, and then here will be going up. Okay, so that will be the graph of y equals to negative tangent x. So what if it's negative tangent, okay, what if it's, this is 3x, huh? Okay, what if it's 1 minus tangent 3x? So this is actually negative tangent 3x plus 1. It means that the graph has raised by 1 unit. Okay, the whole graph has been raised up by 1 unit. Yeah, so 1 unit, let's say here from 0, it goes to 1 here. So I draw a line here. Okay, so it will be 60. Here is 120, and here is 180, which is pi. So x, so this is y, equals to 1 minus tangent 3x. Okay, so the graph will be going down, then it will be going up. Okay, and then here the graph will go down, and then here will go up, and then after that here will go down. Okay, and then here will go up like that. Okay, let me draw this nicely so that it looks more like a curve that goes up to infinity. Okay, like that. So that will be the graph for 1 minus tangent 3x. Okay, hence using the same axis, sketch a suitable straight line to find the number of solutions for the equations. Okay, the equations given. So state the number of solutions. It means to find the number of solutions, we find the number of intersection. Okay, so for this, for the graph just now, we can put this as pi, and this will be 2 pi over 3. Okay, and 60 will be pi over 3. Okay, because it's 180 divided by 3 is 60, and 2 over 3 times 180 is 120, and pi is 180. Okay, so now to find to answer this question, so I'm going to write the working. We have to do some working. Okay, so 2x over pi, then plus 3 tangent x minus tangent cube x, then over 1 minus 3 tangent square x, and equals to 0. So we know that, okay, this whole thing that we found in A just now, it was tangent 3x, okay, the one that we have proven just now. So it will be 2x over pi, then plus with tangent 3x equals to 0. Okay, and then after that, we need to find what is tangent 3x, but we need to get negative tangent 3x. So if we put negative tangent 3x, which means that this one we move to the right hand side. Tangent 3x, we move to the right hand side, it becomes negative tangent 3x. Okay, so equals to 2x over pi. Okay, then, but we need to form this. Okay, which means that we need to plus 1 for both sides. Okay, so here we plus 1. And then here we have plus 1 too. Okay, and we know that, okay, y is equals to 1 minus 3x, which means this one will be y equals to 2x over pi plus 1. After that, okay, to draw this straight line, we need to have 2 coordinates. Okay, so I'm going to find what are the 2 coordinates. Okay, so let's say this is x, this is y. Okay, so when x is 0, y is 1. And when x is pi, so pi over pi we can cancel, so we get 3. So this is pi, and this is 3. Okay, so we have these 2 coordinates already, okay, which are 0, 1, and also pi 3. Okay, so we are going to plot it on this graph. Okay, so 0, 1 is over here. And then pi 3, so pi is 180. Then 3, okay, let's say it's somewhere over here, 3, so it's here. Okay, after that, we join them with a straight line. Okay, so here, we join to here. Okay, so can you see how many intersecting points with the graph? So we have, okay, let me use another color. Say I use green. Okay, so we have here 1, 2, 3, and 4. Okay, so the number of solution is 4. Okay, so you have to write it down. So number of solutions is equals to 4. That will be the answer. Well, that's all for now. Do you want me to continue discussing this paper? Let me know in the comments below. Like this video if you like it, and subscribe to my channel if you haven't, and I hope to see you in my next video. Bye!